Alright, you're going to be simplifying radicals this week. Simplifying radical expressions. And a radical expression such as 2 times the square root of 3, or the square root of x plus 3, is an expression that contains a radical. A radical expression is in simplest form when, and there's 3 criteria. No perfect square factors under the radical, no fractions under the radical, no radicals in the denominator. Okay? No perfect square factors under the radical. So right now on your paper, I want you to create a list of perfect squares. And we're going to call it the first 15 perfect squares. Okay, let's go back up to this first criteria. No perfect square factors under the radical. Put a comma there and put other than 1. Other than 1, meaning the number 1. Alright, so if the first test for a radical being in simplest form is that it has no perfect square factors under the radical, let's list the first 15 perfect squares. And the first 15 perfect squares are the square root of 1, 4, square root of 9, square root of 16, and the square root of 25. What's next? The square root of 36, and then 49, 64, 81, and the square root of 100. square root of 121, square root of 144, 169, 196, and the square root of 225. Everybody understand where those come from? Square root of 1 is 1 squared, right? 2 squared is 4. 3 squared is 9. 9 squared is 81. Those are the first 15 perfect squares. Okay, and then write this down as well, please. Multiplication property of square roots. Multiplication property of square roots says that the square root of 48 is equal to the square root of 16 times the square root of 3. And the square root of 16 is equal to what? 4. So the square root of 16 times the square root of 3 is the same as 4 times the square root of 3. Now, some of you, I like showing this property vertically. So we'll take the square root of 48. Let's do it vertically now. Square root of 16 times square root of 3, which is the same as 4 square root of 3. Alright, so let's take a look at a couple of radicals that are simplified. And then a couple of radicals that are not simplified. Okay, simplified. 3 times the square root of 5. 3 times the square root of 5 is simplified because there are no perfect square factors under the radical. There's no fractions under the radical, and there's no fractions in the denominator. 9 times the square root of x is simplified. The square root of 2 over 4 is simplified. Each of these 3 radical expressions meet the criteria. Three times the square root of 12 is not simplified. Can someone tell me why it's not simplified? Yes. Say again. 3 times the square root of 12. The first criteria for a simplified radical. Yes. 12 has a factor that's a perfect square, doesn't it? Okay, that's why it's not in simplest form. Because you can rewrite the square root of 12. You can rewrite this expression as 3 times the square root of 4 times the square root of 3. It has a perfect square factor under the radical. And then this would simplify to 3 times 2 times the square root of 3, which is 6 radical 3. And now it is in simplest form. the square root of x over 2. Why is that not simplified? Yes. Can't be a fraction under the radical. That's a fraction under the radical, isn't it? Okay? So that's not simplified. How about 5 over the square root of 7? Why is that not in simplest form? What is? There's a radical in the denominator, so that's not in simplest form. Okay? So those are 3 examples of the 3 rules for being in simplest form. Alright, so now we're going to practice simplifying some radicals. Okay? When you're asked to simplify, and you're given the square root of 160. The first thing that you do is you take your calculator and you turn it on, and then you take 160 and you divide it by the square root of 4. You go through your list of perfect squares and you start dividing. And you find the largest perfect square that goes into 160 evenly. Understand? So divide your 160 by 4, and then by 9, and then by 16, and then by 25, and 36. You take 160 and you divide it by 4. Okay? Does it go evenly? Yes. But is it the largest perfect square that goes into 160? You don't know yet. So then take 160 divided by 9. Does that go evenly? No. You got a decimal, right? So then you type 160 divided by 25. Or I'm sorry, 16. Does it go? Then you take 160 and divide it by 25. And then by 36. And then by 49. And if you look down your list of perfect squares, is 64 going to go into 160? No. So what's your largest perfect square that goes into 160? The square root of 16, and how many times did it go? So the square root of 16 times the square root of 10 is equal to the square root of 160. Now, your 16 is a perfect square, so this becomes 4 times the square root of 10. That is your simplest form of the square root of 160. That is the process that you do every time you're simplifying a radical. You take the number under the radical, and you start dividing it by all the perfect squares until you find the largest perfect square that will go in evenly. Alright, so try the square root of, 24. And when you're done, do you get that? Anybody confused or have a question? Try the square root of 72. Simplify the square root of 72. Start dividing it by perfect squares and find the largest perfect square that goes into 72 evenly. Did anybody get 6 radical 2? Who's confused? Speak up if you're confused. Raise your hand if you're confused. Okay. The question was, how do you only simplify one side, not the other? Meaning the 36? Because 36 is a perfect square. 2 isn't, is it? So the 36 is the only thing you can simplify. And if you find the largest perfect square that goes into the 72, then it becomes a one-step problem. All right? Anybody else have a question about anything we've done? Because if you get confused today and you don't address it now, then you're in step 1 of chaos theory. Which means that tomorrow you're really not going to know what we're doing. And Wednesday you're going to think that we're trying to send a spaceship to outer space. Thursday you're going to be clueless. And then on Friday you can't finish the quiz because it's too hard. It's a snowball effect of not understanding what's going on Monday and addressing it. Yes?
How do you find the 6, the 2, and the 4 again?
The 6, the 2, and the 4. This 6, and this 2, and this 4. The square root of 16 is equal to what? 4. All right? And what's the square root of 4? 2. And the square root of 36 is 6. That's why when you're dividing originally, you're trying to find the largest perfect square that goes into the radical evenly. Because those perfect squares all simplify to whole numbers. Right? Back here on this list of perfect squares. Tori, you don't mind stop talking while I'm trying to explain this, do you? All of these perfect squares. These are perfect squares because the square root of 25 is equal to 5. And the square root of 100 equals 10. The square root of 81 is 9. The square root of 64 is 8. 49 is 7. 36 is 6. You're trying to find numbers on this list of perfect squares that go into the number evenly so that you can simplify. Okay? Because if the number isn't a perfect square, you can't simplify it. In your calculator, if you push the square root of 5, you're going to get a decimal. Non-terminating, non-repeating decimal. So you're only looking for perfect squares that go into the number under the radical evenly. Okay? If you were asked to simplify something like the square root of 21, okay, you divide it by the square root of 4. Does that go? Does 4 go into 21? No. You divide it by 9. Does 21 divide by 9 evenly? What about 16? Is there any perfect square that goes into 21 evenly? No. So this is in simplest form. It's finished. You can't simplify it. It can't be factored. Okay? But if you take something like simple, like the square root of 20. Right, but 10 is not a perfect square. Everybody thinks of 2 times 10. You have to learn to start thinking in terms of perfect squares. What's that? And 2 is not a perfect square either. But 4 is. The square root of 4 is a perfect square. So the square root of 20 is equal to the square root of 4 times the square root of 5, which is 2 radical 5. That is in simplest form. Okay? You got to start thinking in terms of perfect squares. And that's why we wrote the list down. Anybody else have a question? What about the square root of 18? What's that? 3 and 6. But are either 3 or 6 a perfect square? 9. Alright, so you use square root of 9 times square root of 2, which is 3 radical 2. That's your simplest form. You're dividing this number that's under the radical. You're trying to find the largest perfect square that goes into it evenly. And when you find the largest, then you can simplify. That make any more sense? Anybody confused? Now's the time to speak, to raise your hand, to address your confusion. Okay, your best bet for these practice problems is going to be to take a picture of them. And those aren't them. Those are. Okay? And that's your practice assignment for today. Do it on a clean piece of paper. Show each step like we just did in the notes, and you're going to simplify those 17 radicals.